zone,
Yeah, yeah.
and allow the connectivity to be delegated to us, and connectivity and the security.
So there's a whole bunch of people building these new connected hardware devices, thanks to Kickstarter, thanks to labs like Highway One that'll help you build it and build it at scale, right?
Yeah.
With the supply chain over in China, and the costs of hardware, computing hardware on things is coming down.
Oh yeah.
Right. What does that kind of entrepreneur need to know about this new world and your devices, you know, to integrate this into what do they need to think about before they even get involved with you?
I mean, I think one of the things is a lot of people look at hardware and they just look at connected devices. They look at the connectivity as a hardware problem, partially because chip vendors want them to. So it's like, oh, here's a Wi-Fi chip. There's your Wi-Fi problem solved. That's not the problem solved if you're making a product. So a lot of people are looking at this stuff. They build their design out and they like make one that works. And it's usually quite easy with all the prototyping, the Arduino and so on, Raspberry Pis, to make one of something that works.
Yeah.
But then there's a huge leap to production. It's like you can make one. Could you make 100? Yeah, you could buy 100 Raspberry Pis and manually put them together and stuff. Not going to scale so well. But then they're unmaintainable in the field. The thing about what we do is that it's like it's not like a prototyping platform. It's more a commercial platform that you can buy one of for $25.
Yeah.
So I think people building hardware, it's always like, yeah, it's harder than you think if you've not done it before.
They call it hardware for a reason. Right?
They call it hardware for a reason. And some of the reasons are it's like, you know, you iterating on the actual hardware bit is very hard. When you've shipped it, you can't. It's out in the field. It's there.
I learned this at a video capture card company, and we were building a new camera, and the plastic was wrong, and we had to wait another 4 weeks for the new updated plastic to come back from China. Right?
And that's really quick, 4 weeks for a new plastic tool, yeah.
Whatever it was.
But I'm sure that was rushed through, yeah. So, I mean, that's one of the things you have to be really, really, and I've spoken at some sort of startup meetups and talked about hardware and some of the things, it's like when you make hardware, you want to do everything you can before you ship the first one to be sure about it. It's like when you build 10 prototypes and one doesn't work, find out why it doesn't work, because it will come and bite you later. Because if you have a 10% failure, make 100. Now there are 10 that don't work. And you know, I really learned this lesson at Apple when, you know, on early iPhones we were making 100,000 a day, and it's like, oh my God, if you have a 0.1% failure, this is a big thing. There's a big queue of people at the repair station trying to get this thing worked. So you want to find those problems and understand everything about you know, what happens in low battery mode, what happens when it's just out of Wi-Fi signal. Understand all of that at the beginning.
And even Apple got it wrong here and there, right? I mean, you know, I've heard lots of stories because my friend worked at Apple with you, you know, on the Bluetooth stack, and he told me lots of stories of where they burned up prototypes and you know, didn't understand what caused the thing to burn up.
and we'd run into problems post shipping, which were like just a weird combination. There was one problem which only exhibited itself that we knew of at the 280-85 interchange when you were on a phone call at full power in a certain charging dock, which wasn't designed for phones. It managed to kill the phone, and we spent months looking at that problem and trying to replicate it. But you know, and we fixed it for all the iPhones beyond that point. It was just like we thought we'd made it robust enough. Turns out that if you happen to be driving on the freeway right by Apple, where there were 2 different cell stations and it handed over in a weird way, you know,
and that sounds like Steve Jobs' commute. So I bet he was yelling at you.
There were some interesting ones. Like there's a certain senior Apple guy. You know, we'd rate the early iPhones after the first iPhone was before it was launched, but when people were carrying it, it was like. And it'd be like, it still drops my call on my commute down from San Francisco. And it'd be like, you know, after a certain release, it's like, doesn't drop anymore, because he was always on a conference call every time he went through a sort of a dead spot on 280.
Yeah.
And it was like, well, the reference phone didn't drop it, and this one did. So, yeah, I mean, it's very personal. That's why actually, you know, there was always this thing about testing phones and carrying them. And I was one of the guys who was lucky enough to have carry access on early phones, and it's a real responsibility. Everything you find, you have to talk about, because it's going to be multiplied by, you know, 100 million or something when they actually get out in the field.
Yeah.
But it's testing is critical, and and I advise that for startups. Like you make a connected plant watering system, get 100 of them out there with friends, get them to whine about every last detail, because you are going to have paying customers whining at you soon. You want to make sure there's nothing to whine about.
So how do you help the entrepreneur
how do we
prepare for this kind of hell?
Well, I mean, one of the things that we do is there's obviously a lot of complexity and connectivity, both in writing your server code and dealing with embedded software. Embedded software is a very specialist art, really, because it's like, well, you have this as 128K of RAM. It's like it's been back in the early Mac days. There's very little resources, and so we deal with a lot of the intricate parts about TLS connection setup and all this stuff like that, and allow them to think about their application. So the way we help entrepreneurs specifically is you can buy this for $25. You can prototype your solution. Even if you end up, you find that we're not suitable for whatever you want to do, and you have to use another one. But the point is that you can actually use our solution, make something work, and iterate. And that's iteration is the heart of any startup. The fact you get to iterate is the great thing about startup. Yeah. You're not constrained by project schedules necessarily. You want to get something out there, but you have in your mind what it has to be and how good it has to be.
What does this look like on the screen? Because we don't have a demo or anything.
No, I didn't bring it up.
And what does an entrepreneur need to know about the first couple of hours of when he gets his first one?
When he gets his first one to prototype. So we have a really easy way of getting started. We have like a web-based IDE. So basically, you configure this, and the way we configure it is actually using the screen of your phone. So one of the things about Wi-Fi devices is how do you set up the Wi-Fi credentials? So we do it using the screen of a phone, and we have a patent-pending technology called BlinkUp, which uses flashing of the screen to send the SSID and password and stuff to the device. So the first thing you get out of the box, you do this thing with your phone, it's online, and then it appears in your web-based IDE, so you can actually use a Chromebook for serious development. You write your code in there, you can see the debug. I mean, and that's one of the things is you just get started incredibly fast. You can have it, the blinking an LED when connected to the internet, so I can hit a URL and make an LED go on and off, which is kind of one of okay, I have a connected device. That's the aha moment. It's like
it's like the hello world.
It's like hello. It's hello world. Well, blinking LED is a hello world for any microcontroller. It's like yes, it's running code, but this is like it's fully connected securely to the internet, and that's like 15, 20 minutes.
Can it interface with basic Stanford Raspberry Pi? Does it have an API for those?
You can, but this actually has. Okay.
So let me talk. Okay. The question was, is there a way to use the stuff from Raspberry Pi or other prototyping environments in here, or do you have to rewrite your code for the Electric Imp?
I mean, you can use it with. I mean, Raspberry Pi is kind of like that's a Linux machine, so it's like that's actually much more connected. The problem is people use Raspberry Pi because it's cheap for doing completely inappropriate things. So if anyone 10 years ago said, I'm using a 700 megahertz 32-bit processor to turn a relay on and off, they'd just be like, this is inappropriate use of technology. It's overkill. But you can use this with Arduino. You go to SparkFun. You can buy a connection kit which will connect it to an Arduino, so you can run your Arduino code, but then make it speak to the internet. But actually, the resources this has about 40 times more memory than an Arduino does. So if you want to use Arduino, fine as like your processor, but you'll find it's actually easier to use this as the processor because it's 32-bit and has 80K of RAM and all this stuff like that. So you can use it to interface. And I think what people generally say when they say Arduino, it's like, oh, can I use these sensors I bought off SparkFun to connect to it? It's like, yeah, you can. You just plug them straight into this and it works.